A blockchain can settle billions of dollars in seconds and still fail completely if the data feeding it is wrong. Price feeds, FX rates, collateral values, compliance signals. None of those live on-chain by default, and yet everything depends on them. The real risk in blockchain finance isn't volatility, it's bad data moving at machine speed. Modern finance already runs on automation. Trades, margin calls, treasury movements, collateral adjustments, all triggered by data. The paradox is that while blockchains promise deterministic settlement, the inputs driving those settlements often come from outside the chain, from systems that were never designed to be trustless or decentralized. That disconnect is easy to miss. Most conversations focus on throughput, fees, or decentralization metrics. But institutions don't start by asking how fast a ledger is. They ask what happens when the data is wrong, delayed, manipulated, or disputed. Because in real markets, that's where losses actually occur. This is where the decentralized oracle problem enters the picture, not as a technical curiosity, but as a structural fault line between blockchain narratives and institutional reality. Everything here is for educational and entertainment purposes only, not financial advice. Always do your own research before making any investment decisions. If clear, no hype crypto education helps you make sense of all this. Hit like and subscribe. It tells YouTube this series is worth showing to other newcomers, and it helps me keep building it for you. At its core, an oracle is simple. It delivers information from the real world into a blockchain environment. Asset prices, exchange rates, interest benchmarks, identity attestations, compliance signals. The problem is that blockchains are excellent at verifying internal state, but completely blind to external truth. In early crypto markets, that limitation didn't matter much. Most activity was speculative and self-referential. But once you move toward tokenized treasuries, regulated stablecoins, or automated liquidity systems, external data becomes unavoidable. Settlement logic is only as good as the information triggering it. This is where many systems quietly introduce trust back into a supposedly trustless stack. A single data provider, a small committee, an API endpoint everyone just hopes behaves correctly. It works until it doesn't. DeFi oracle systems were designed for open markets where failure is tolerated as risk. If a protocol is exploited, liquidity moves, users absorb losses, and the system evolves. That model does not translate to regulated finance. Institutions operate under audit requirements, fiduciary duties, and regulatory oversight. They cannot accept opaque data sources or probabilistic truth. A pension fund, a bank treasury, or a payment network doesn't get to shrug off a bad price feed as market learning. The incentive structures are also different. In DeFi, oracle operators are often rewarded for participation. In institutional systems, incentives are tied to accountability. Who provided the data? Under what rules? With what liability? Those questions matter more than decentralization slogans. Institutional data systems prioritize a few things above all else: provenance, redundancy, auditability, and determinism. It's not enough for data to be decentralized. It has to be explainable after the fact. That's why traditional markets rely on reference rates, benchmark administrators, and regulated data providers. Not because they're perfect, but because they are accountable. When something breaks, there's a clear chain of responsibility. For blockchains to support real-world assets, automated treasury flows, or large-scale liquidity routing, they need data architectures that mirror those properties, without reintroducing single points of failure. The XRP Ledger introduces an additional constraint that often gets overlooked. It was not built around general-purpose smart contracts. That wasn't a limitation. It was a design choice. By focusing on deterministic execution, native escrow, built-in exchange functionality, and predictable settlement, the XRP Ledger reduces attack surface. But it also means oracle integration must be deliberate. There is no assumption that arbitrary external logic should be trusted by default. This pushes Oracle design toward fewer, higher integrity data interactions rather than constant, noisy feeds. That philosophy aligns naturally with institutional finance, where fewer decisions carry much higher stakes. As automated market makers mature on the XRP Ledger, the importance of data integrity increases. Liquidity pools depend on accurate pricing, correct asset ratios, and trusted reference values to function properly. If pricing inputs are distorted, arbitrage doesn't correct the system, it exploits it. In institutional environments, that isn't just a market event, it's a risk event. This is why Oracle integrity is inseparable from liquidity engineering. You cannot build reliable settlement rails on top of unreliable inputs. The two evolve together. The future of Oracle systems for institutional blockchains likely looks hybrid. Multiple data sources, cryptographic verification, reputation and accountability layered together, zero-knowledge techniques to prove correctness without exposing sensitive inputs, not fully permissionless, not fully centralized, structured, auditable, and resilient. This mirrors how institutions already think about risk: redundancy over ideology, verification over assumptions, systems that fail gracefully instead of catastrophically. Blockchains don't replace trust, they relocate it, from institutions to infrastructure, from people to systems. The decentralized Oracle problem reminds us that settlement isn't just about moving value. It's about knowing why value moved, under what conditions, and whether those conditions can be defended after the fact. As the XRP Ledger continues its institutional evolution, data integrity becomes the quiet foundation beneath everything else. Not exciting, not flashy, but essential. Thanks for watching, and I'll see you in the next deep dive. This channel is for educational and entertainment purposes only, and is not financial advice. Always do your own research and keep the discussion respectful. If you enjoyed the video, please consider liking, subscribing, leaving a comment, or sharing it with a friend.